Okay, I will be making what do you call it? A catsu learning platform. The system will pretty much be focused on learning platform with a bit of school management because this thing is pre-made already, so I might as well add it. But before that, I can that challenge myself to explain first how can this thing be connected to a learning platform. Okay, the learning platform would be a school focus based platform, meaning that it will be generally used by one school and one school only, and then all the materials that the school has will be put to this platform. Qua- This is done so that it is more tailored to the school itself, not just like an academy that tailors for everybody. That's fine, and actually, that's actually better. But we cannot afford to make something like that for now. And then, so the focus is katsu, for example. And how will all these things relate? Before I explain it, I want to explain the learning platform first. What this since this time is pre-made with all this thing, I will just read this first. I want to expand the system to what I proposed to Seisel, which was Katsu Online. It's pretty much a learning platform that is connected to Katsu system, but I will make it myself this time, okay, because I am prone to like using AI, not connected to Katsu shit. What I want the system to be is an online school game like system where students can discuss in forums where they can post comments like Twitter. They can take quizzes and view past lesson that is pretty much in all levels. This will help them in their advanced studies. I just the system will pretty much be a centralized learning platform for what is it called? Each course. Meaning a course for say city would be most a different one from this and for agri and for or whatever. And the lessons or what will be mostly provided is the past lessons and our pre-recorded video. The video would be actual lesson taken when they're teaching it to students, not like whatever lesson they want it. It can just be a normal video taken from each class to until a complete one. Which it's like an everyday thing. So I have to worry about the storage of this thing because pre-recorded one is not that easy, especially if it's not even especially if it's not tailored one. And just actually posted. I mean, this can just be done by YouTube, but also you can let you do that. Okay, the files and the video will be included, and mostly the management part of this of school will not be considered here, like the grade and attendance. It is just a centralized form where students can find lesson, past or future, get learning materials, and maybe take quiz and activities. It would be better if this is an API sheet, meaning it is a separate front end because Katsu right now has a backend that has school management fees that consider fees, expenses, rooms, classes enrolled, and grades. So it would be better if was just a learning API front end that I can just connect to a backend, which would be fine. But since this is a personal project, I can just do this. And if in the future they decided to make something similar, at least I can Hey, I make something like this before, can I join? Something like that. Exactly. Now, before I talk about like the annoying part of this thing, we have to explain this thing. As of now, what this is just well as subject, a department, enrollment, the classes, the faculties. Faculties the are the user or probably the admin and the staffs. This is small and in classes will be classes where most enrolled student will be at enrolled, if you know what that is. Department would be like the each courses. We got like say city, ABM, agriculture, UMS, nursing, and law. And subjects just subjects under department because that's it. Now, how will this thing connect? Since the system is more on a school-based focus, not like an academy, all this thing would be good because subjects subjects can be used as for student to find lesson. Let's say in this subject we want to find a lesson about this, in that, or files that was used in it, whether it be past or the future. Of course, it would be nice if we have like a grading year, like first, second, and third, so forth. This way, it can be easily manipulated. Also, yeah, okay, that's fine for now. And departments will just be departments. This thing don't actually matter that much now that I think about it. And enrollments. Hmm. This is good for the learning platform part. Yeah, this will be good for the learning platform, but because as I said, this is not an academy. This is a more focus based on each school. So having enrollment is good here. We will just not care about the attendance and whatever. This is just good enough. Subject, I still do not know what is that thing for. And say, yeah, I mean, it would be good because I said before it could be used for categorization, and it would be good because this is a separate table. It's not like we can just put it in one table like classes. That's stupid. Okay, since I cannot really explain this thing much, since I didn't really make it and I don't know much about school management, classes, the same work, where students are enrolled, which departments you belong, what, you know. We will not consider, we will not consider what, what, subject is it is being taught, what time it is being used, and so forth. This thing will just fully be purpose of the enrollment and belong to the department. That's it. Because this thing could be the building. This thing could be the class in it. I mean, not really good because this thing doesn't mean anything. This just means that it owns this class or I mean subject. Faculty, this is just the employee management, but it's not really that important. It will primarily be used for knowing who is the admin, the staff, what they can do and what they cannot do. And it can also be used on which class they taught, what subjects they taught, and shit. Hmm. I think I'm over. I don't know if I'm over engineering or what, but anyway, that's for it. Of course, what I'm saying right now is pretty bland. I mean, It's pretty shallow because there is so much more about this that I simply cannot fathom right now. But for now, I will accept that. I will just rewatch this video anyway just to understand it more. And the more I watch it, the more I will probably learn about it. For now, that is why I would not remove this from the learning focus of this project because it is a tailored one for each school. So having all these things is good because each school has different subjects. I mean, all of them has, but some of them are not always the same. Like the material, the level, it is not always the same. This thing is just for big school like catsu, but for a small one, it's not really needed. It would probably be changed to something like grades or something. Enrollment is just for the learning platform because the way we are doing this is when a student is enrolled, the first thing they will see is like something like this. Just this thing, just like the Google class, where they will see classes that they are enrolled to. They will see the classes that they are enrolled to. They will see who is the professor or the faculty member. They will see the subject name. And once they click that, they will be they will be given or migrated to a new view which will have all quiz, activities, and lessons. It's pretty much the same as Google Class, but Google Class is not really connected to the school itself, is it? Right? Let me check. Yeah, this system will be pretty much like Google Classroom with a bit of game. So this is with game. That's it. This system will pretty much be a combination of this system will be a combination of Google Classroom and game element like an academy. Okay. And let them research. Yeah, this system is Google Classroom plus game element plus a bit of school management. A bit ambitious for 2 months, but this is a bit ambitious for 2 months. But this is mostly complete. Super ambitious for 2 months, but this is mostly complete. I don't have to worry about that thing. I only have to worry about this two in the design. Now, um, I am learning system design right now, so here are what I think is the problem. Um, I need to think about how this thing will actually work. When I say that is, will this be a SAS thing? Meaning, school katsu, oh shit, meaning katsu and, okay, let me just make this stop. Meaning katsu and national high school will have different views. Meaning this guy will have its own storage and this guy will have its own storage. This is also ambitious, but we need to think about this now because of scale. So let's say these two are our clients. Now, if we make a system to be able to handle these two customers, then we need a system that can account for too many users using it at the same time. We need to account for too many users using it at the same time. Because imagine if this guy uses it for, let's say this thing as users of, okay, let's say katsu. Katsu has about, um, wait, let me fix this. Let me put this here. I will understand it later anyway. Let's say katsu over here. Let's say katsu has a user of about, hmm, let's be generous and let's give it, how many? Let's give it 10 million per user, and this thing has 5 million per month. What the fuck do I mean per user? Per month, per month. And this thing has as 5 million per month. Now, if the system I am making is as a type, meaning these two needs to be at the same backend. Like there's a DB for this, different DB for this, but their backend will be almost the same, and they will be almost the same. So it's like imagine two users of the same system, but they're not two users. They are two different customers. And this is bad. If we are making a system like this, we need to consider this thing. That's pretty much, it is not 10K per month. Or 10K for catsu and 5K for CNH National High School. The system would pretty much be like 15K per month. And we need to consider this thing. Scale up to this thing. There's a problem with this. Scaling would be hard. And scaling would be pretty hard. So, okay, I need to write this thing because I probably will not even like look at this thing. I mean, I will probably remember it, but I probably won't actually watch it. That's fun. Smart. Why am I even recording this? Practice, just remember it. Okay. This will be 15 per month. Now, we need to Skype for that thing. Also, if we are doing this thing, we have to ask. We have to ask what kind of multi-tenancy will it have? Will have the will it have the one, the two, or the three? The one multi-tenancy would be pretty much one database for all of this thing, which is fine. Will it be fine? I mean, that's not. It kind of depends on how big the school is. If the school is like a small one, like National High School, it's fine to do one. Okay, let's name what the fuck I'm talking about so that it's easier. Where can I put this? I'll just put it here. Multi-tenancy. Tenancy. That's spelled wrong, but I don't give a shit. Okay, wait. I have a number this time. Tenancy. I have a name for this thing. Um, it's like, it's name A, B. Okay, what the fuck? Okay, let's do this. Tenancy A. Let's put this thing in different colors. That's it. Okay. Tenancy B and tenancy C. Okay, just for context, tenancy is a shared one. A shared, okay, that's too small. A shared DB. And tenancy B is, how do I call this thing? It's pretty much the same. It's a shared DB, shared DB, but with different tables. And this thing is just separate DB. Now, I will explain each first, then I will talk about this thing. Also, I'm kind of forgetting about this one because I don't really know how to do that. I will just, this is a pretty scrambled lesson or video, but I don't give a shit. In here, all we need to do is that we need to have an API or a request handling or a load balancer that can handle this thing per month, and it has to scale too. We need to know if this thing will scale hori- horizontal or vertical. What the fuck is that thing again? Forgot. Horizontal means um, fuck, I forget. I think this is not horizontal is not for here. This is for the DB part. As we cut it for now. This is for DB. All we know is that this thing needs to handle about this thing. A load balancer that can handle this. It can handle this because the process of this thing would be, I don't expect this thing to scale pretty much. I don't expect this thing to scale, so it would probably load balancer to one server. That's it. That would be it. Because I will not actually do not know how to handle the server part. Wait, let me check. Oh, the load balancer is the DB. Okay, then we need to Google that. Because if this thing cannot, um, let's say a student here wanted to take a quiz here, then what will happen is once they click the link, once the student click the link, or no, once the student click the link for the quiz, it will as a request, it will create a request of get, which will hit this thing to this thing will hit the server, and then the server will give back what it was asked for, then this thing will give it back. This is like the middleman of everything. Middleman. Middleman. Oops. Middleman of the server and the front end. That's good because this thing will most likely hit, or this guy will load balancer. This way will carry all load that is of all of this, then and it will only ask this thing one by one. Meaning if all of them ask, all of them will be hitting the same server over and over again. For writes and read, this thing will just handle all that. And this thing will ask this thing one by one. That's why it's called load balancer. But I do not know much about load balancer, so I will just all that is I will say now. As I was talking before, we need to know multi-tenancy. Multi-tenancy is pretty much multi-tenancy means your system is like Facebook where one user can do the same action, same reads, and watch the same videos at the same time in real time. Okay, this matters because we need to think about the rights, oh shit, the rights and read. We need to think about the rights and the read. What do I mean by that? Let me just to talk about this one by one. Let's say this learning platform system as this thing sorted out. Now we need to think about how will the DB do its thing. It could be if we pick multi-tenancy A, meaning shared DB, that means these two will be in under one database. Let's say they have a table, both of them have, there's a, let's say, hmm, um, subject class or subject table. Let's say subject table, subject. Now, if these two are under one DB or shared DB, which means both of them have the exact same subject table, meaning if katsu has, let me, oh wait, let me do that to make it easier. Let's say katsu. Okay, what the fuck am I doing? Just do it like this. Okay, let's say katsu has a subject of, what kind of subject would that be? Let's say something simple. Arts. Arts. Let's say this one is for katsu, and then we also have a subject for national high school, which would be arts and design. No, all of this thing would be under one DB, meaning the data for this thing and this thing and this thing would be all here. It doesn't matter. It doesn't really matter whether if they have the same name, meaning the uh, if they have the same name, then like this thing, if they have the same name, like this one for Katsu and this thing for National High School, then National High School does not have to create this thing anymore. They just have to select this thing as a subject. But if they want to create their own subjects like this thing, then this thing would be two records. I mean, it's understandable because two school doesn't, even if the subjects say as the same name doesn't mean it taught the same thing. because of grade level. But like this, shared DB means shared table. Let me fix them. Shared DB, shared DB, and okay, and shared table. Now, I'm talking about this thing because of this thing. If there are too many reads and writes, all that will be eating this thing. You can imagine 50, 15K, or I mean 15 million users is hitting this little thing for reads and then writes. I'm over exaggerating, but imagine all the reads that will happen here. That's too many. So we need to rely on this thing, but we still need to make sure to design this thing for scale in the future. Okay, where was I? Okay, imagine this thing having reads of this 15 million per month. That's too big just for this little thing. But although multi-tenancy is good for this because we already have data for this thing and for catsu, the national high school just have to select this one, not create their own, and that's good. Why would it be good? But but the thing is, if there was something, the thing about multi-tenancy is if one thing goes wrong, let's say the server goes down, then the server for this thing and this thing also goes down. And if the traffic on this thing becomes too high, then it will be affected. This nationalized school will be affected. Pretty much, they not only share the same DB, but they also share the same load and stress. If this thing slows down, if the system slows down because this thing become traffic, all of a sudden, this guy will feel it. And there's nothing you can do about that. And that's generally fine. This is simply the simpler way of multi-tenancy, or the most common one. Because this thing can be, I mean, if I were to pick this thing, I need have, I need to make sure that I have a plan. If I were to pick this, if I pick this, then I need migration plan, migration plan meaning how will I, in the future, how will I convert the, how will I get the data from here. Let's say in the future, I want to upgrade the system to a multi-tenancy B instead of A. Then I need a migration plan to transfer all my data to migration B. Okay. Then I also need, I mean, this is not really a need for migration, but backups. Backups, because although all of them need backups, this backup will mostly be targeted on this supporting migration because we need to be careful when we are backing thing up because because in migration something unexpected could happen, an error or a delay that can just ruin migration. So we need a backup always. What else? Wait. migration plan, and testing. I don't really need testing, but sometimes I will just put it there because why not? Okay, that's mostly for multi-tenancy. Having this thing is good for small one. Like this thing, if this thing was mostly made for Catanduanes, then multi-tenancy A is more than enough. Because yeah, I think this is enough. Multi-tenancy B. Multi-tenancy B is almost the same as this thing. Let me copy it. Multi-tenancy is I really need to fix this shit. Alright, I have a video, so I can just watch the video, so it's fine. But let me MB multi-tenancy B. In multi-tenancy B, it's not the same, but it's not far from what that thing is. Multi-tenancy. Multi-tenancy B. Now in here, in multi-tenancy B, it is it is shared TB but with different tables. Meaning this subject is mostly for catsu. And this subjects is for an high school and high. This is pretty much NB, MB, multi-tenancy B. Although they share the same database, they have different tables. This me as for the scale part, I forgot how to. The good thing about this thing is if this thing broke, this thing will not be affected. Like if something goes wrong here, a bad table or no bad validation check for the DB, this thing is not affected. This thing is not affected. Also, the read in writes for this thing would be faster. Not fast enough, but at least it is faster than this thing. Because we're just querying one thing with a small number of DB. As for this, where let's say catsu. Both of them search for projects, or a student search for project. If we have multi-tenancy A, then that would be a lot because Katsu and Enhai has a record in there, has a record of subjects. But if it's this thing, it's just one table, that would be just a bit few compared to the first one. Okay, but it still creates the same problem as NA or yeah MA. This thing still carries the same problem, which is if n if n high encounters a problem or have too much traffic, this thing will still be affected because they are in under 1 dB. They do not have the separation. Yeah, they do not have the separation of both as long as they're under 1 dB. If one of these things even have high experience high traffics, both of them will still slow down. But the DB is more organized, it has smaller data, but the problem with this thing is this thing bloats fast because wait, let me what is more expensive? Eh, okay. This also have its own problem. Let's say I didn't talk about this. I forgot about it. But oh no, I did talk about this. Oh no, I did not. I will talk about it that in a separate one. In MA, we also need in system design or database design. We need to think about we need to think about read. Oops, we need to think about write, update, update, and delete. Okay, that's that. And delete and delete. But we also have to think about index, index, joins, and search or the search or queries. In both, we need to think about this thing. In read, how much, I mean, this thing is obvious. Reading, writing, this is more like we need to think about the anomalies in here. What kind of anomalies it will have, this and that, and index and joins. Now, this thing will have a simpler index and joins because we can just let's say we index works is let's say we index art or we index the subject, then it will pretty much what it will do in the DB is let's say we have 100 records and each for each 10 of them they have starting letter of let's say the first 10 is A, the 21 to 30th is B, and the 30 to 40 is C, and so forth. What index will do is what index do is instead of just searching the entire thing one by one. Let's say we did a query. We did a query of subjects and we search for the subject name. Let's say let we search arts. Now as I said that the first query is a okay, let me just write this shit. It's too it's easier that way. I'm gonna watch it anyway. Okay, let me just pause. Okay. The way indexing work is I will just talk about how it search the query or the database. I will not talk about what is an index. But per cap index is a way for the system to search an entire table faster. But it pretty much makes index helps a system search a database faster or read data in the database faster. But the caveat for it is it makes the writing slower. So it's either you have fast reads, shit, either you have fast reads but slow search, slow writes, slow writes, or packetable letter. Either you have fast reads but slow writes, or slow reads but faster writes. It kind of depends. Kind of depends on the system. And this will okay. We'll explain this thing first. So an index is a way for a system to search a DB faster because it does this. Let's say we have 100 records, and in all those 100 records, we search. Um, let's say this record is for fruits. No, let's say subject. Let's say this is for subjects, so that it's easier. Let's say we have 100 subjects in here, 100 subjects. Then 100 subjects. The first 10 of the 100 subjects are wait. In index, the way index does things is it pretty much organize your DB in an orderly fashion. Let's say in here we have art, we got 101, introduction to programming, and agriculture. Well, what index will do is order all of them in numerical or alphabetical order. That's why we are doing this. Let's say in subject we have 100 records. What index will do is it will have a record of this numeric or alphabetical order, and we type in the search function. We type A, for example. Let's say we type A. Then what it will do is it will send a request to the DB to the what it will do is send a request to the load balancer, then to the server or DB. And what index will do is do a search query, a search or what the database will do is search query, then index will come into play. Index, let's say we put B in search. Then instead of searching all 100 records, it will just search this thing, the 10 to 28, pretty much the record way. Instead of searching in the entire record, all 100 record, what index will do is eliminate the 90 that does not have contain the letter B. That's it. So instead of searching 100 records, it's actually searching 10 records, which is faster. And the more the system actually grew, the more these things becomes more powerful. In relatively small database, index is actually not that needed because you are sacrificing rights of reads. And in a small system, you don't really need that fast read because the database is small. Probably you need to think about um how many data will this record actually have before putting index. So We cannot just put index everywhere just because it makes it fast to read. We also need to think about the consequence of index. It may make the read fast. It also make write slower. So think about that. But that is index. Of course, index has constraint that it needs to be followed. Like I have a rule for this, which is uniqueness, quantity, and actual use. Uniqueness meaning is this subject unique? Like is it unique enough that it can be itself? Like this thing, anything that falls under this can be unique. And the quantity, will it be used? Will how many is it actually? Like it can it be if it pass, if it pretty much went fast 100K and it definitely needs to be indexed. And the use case pretty much, will this thing actually be used in join inquiries? If not, why do not need to index it? Like create that. Oh, if you do not need create that, then why index it? Like if you are not using it for search for join, then don't even bother making an index of it. No. Okay. Okay, now that that's been talked about, we also need to talk about the DB type. There is, from what I learned, there are. Okay, wait, why am I talking about this? Let's talk about it later. Okay, how do index relate to this? As I said, index does this thing, and MA in MA that's super good actually because imagine we already have something like this, which all falls under the in the example the first ten because of the A. Now, if we have this thing, which now that's good because for one table, search query is usually super fast. But in here, we kind of have to create an index for this thing, an index for this thing, and I've already told that too much index cause slower writes. And I do not know if index from this to this influence each other, but more or less. Oh, okay. Apparently, index is better here. I just read this. Okay, but that's not really what we need to think about. We also need to update the maintenance. This is easier to maintain and migrate because the catsu and the national high school data are already separated. In here, we don't know what data we do not really know if this thing came from katsu or this thing came from national high school unless we do not know that. So the way we will do this is we will create a special pivot table for this for us to be able to recognize where this thing came from, katsu or national high school, and that's pretty much a join. So that's obviously not gonna be fine, and it is generally harder to maintain in scale. This thing is easier to scale and maintain because everything is already separated. If this thing had a problem, then we can fix the problem here without affecting this thing. Okay, I need to stop saying okay. Shit. Multi-tenancy C, separate DBs. Now this means Katsu. and National High School has a separate DB. This means the problem that I talk about, that if this thing suddenly had a high traffic, it will also cause this thing to slow. If this thing had suddenly ha, if this suddenly had a high traffic and causes this server to slow down, then this thing will also slow down because of the high traffic here, and vice versa. And that's the problem of these two, because they still share 1 dB, which is this thing. But if we use multi-tenancy pretty much mean we don't have to worry about this thing, only one this thing, because it will pretty much be like, um, let me copy it. Okay, this won't even happen anymore. This thing will be cancelled, and then let's just copy it again so it's easier. Okay, what the fuck? The situation is like this now. Katsu has its own server, and wait, this is wrong. It will still be like this. Both will hit the same load balancer, but instead of one server, we will have two. Oops, two. Okay. Server is a database for now. Okay. And just stop saying okay, shish. Fucking fuck. Katsu, oh shit. Katsu has its own server now. So if this thing goes had a or is having a high traffic suddenly, then even if this thing slows down, this thing will not be affected because this is Katsu's. Wait, let me write. This is Katsu's server or database. So if it suddenly had an high traffic, if a high traffic suddenly came, then it will not be affected. It will not affect and high because the read and writes is happening here, not in here. And this thing is owned by Katsu. So this thing has nothing to do with what happened here. It only concerned with what is happening in here. That is multi-tenancy. Okay. Of course, we also have something like, I don't know if this thing is actually done, but usually when we see something like a database, there will be this type of thing. But it is mostly regional. Let's say this thing is for America, this is for Singapore, for Philippines, and this thing is just one app. That's it. So it can be like that. But in this case, we are talking about the learning platform. So this is usually harder. To do this thing is harder because this thing we the good thing is we can create custom tables for this thing. But that is also a lot of work because we also need to move the system a bit just to tailor to whatever this thing is. Unless we just don't allow that. Fuck. Okay. That is multi-tenancy. And it pretty much has the all benefits of this thing, but it has the benefits of these two. Like the only downside of this thing is that it's super hard to maintain and manage, if especially if we had a lot of clients like this. But it's the best, pretty much. If it's scaling. Now let's talk about what DB are we gonna use for this. What do I mean by that? Let me explain for a bit. Different system needs different DBs. Meaning, in this system, we have the admin side, admin, okay, let's not use this thing. We have the admin side and the staff. This is our roles. Then we have students. Now, this requires different types of doing things. Let's say in our system we have a post type Twitter like system. Meaning we are doing reads and writes super fast. Because let's say one guy wanted to post something and one guy wanted to read. Then most of the time those two needs to happen at the same time. So if we are talking about this because of different TVs usually have different function. We got a relational, um, we got document, we got what else? The queue. We have different type of DBs in Facebook. The DB of the admin side of Facebook and the front end side, what we user sees, is pretty different because they have different needs. The staff part needs mostly the read types because most of the time you don't really need to touch or add something new except for the first few that you're using it. But in student you need a lot of rights and also a lot of reads. If we just use relational for books, um, it would cause problems. I'm not talking about SQL or I'm not talking about no SQL, not just that. I'm talking about the read and writes of this thing. Because, because by this thing, no SQL would be the best database. And no SQL would be the best because if we do relational in here, where there are too much read and writes, then that would be bad because it will also affect the joins in here. And we cannot have that thing. We need to at least have a separate type of DB for this too, like Facebook. We can either make this thing relational and this thing document, or we can just make them no SQL, which is one of the best thing, which I'm actually fine with. But I still do not really know about that thing. But in general, the point of this thing is that when we are creating system, sometimes one side needs a different type of database to the other one because of constraint, reads and write in index. But for now, I think we will use NoSQL for this. since it is generally for this type of case, it is better. So I will I will just put here. I'll just fix this. So, okay, we still didn't really talk about what we will be using here. Nothing we will be using is multi A M A. Now let me write this thing. Okay, for the DB part of the system, we will be using MA because the system will not really be that big and it's mostly a project system for fun, for getting a job. So this is simply, although this thing has quite the disadvantage, it pretty much is the best for a project, for a small project. And NoSQL is because we have to do a lot of read and writes. And it's pretty much the most flexible SQL for now. And I don't really imagine we need like complex relational queries for this thing. Like it's not like we are gonna make like super complex dashboard. So we don't need that. We do not need that. And as for the DB of this thing, we have yet to have one. And as for the tech that we will be using, it will be Laravel, yeah, Laravel and React. Tech, tick, tick. There is Lara plus React. So this is an API system. Lara is the backend, front end. That's gonna be fun to manage. And also, I need to talk about whether this thing would be a monolith or a microservice. Monolith and okay, let me just justify this thing. I will be using Lara because it is the most familiar for me. I'm super familiar with it, so this is what I'll be using. And I'm learning this thing right now. And I actually want to use it to learn and oh wait, I'm talking about the oh my god, what am I doing? Express. This is not the best, okay? Relax. This is the tech for now. Plus this is the back end then the front end. And then the auth would be the auth uh is better auth. Better 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 we'll be using better auth. And then the DB will be using Drizzle. Simply because it is closest to MySQL or NoSQL and I really like being able to control what the DB is. And as for API securities, we will be using Arc, ArcJet. We will be using ArcJet and for authorization this is custom. Then we just have to make sure to validate everything. Oh, this thing is called ArcGate. Okay, wait. Go here. Then we do architecture style. Then, yeah, I think mm, this will be using monolith. We will be using no monolith. The fuck will this spell monolith? Monolith. Okay, what the fuck's the shit? This is monolith because this thing is still considered under one thing. These are all JS, and this thing pretty much under one code base. And a microservice means separate backends. We have a backend for auth, for ARN, for API securities, for DB, for all of them are different and they communicate over APIs, which this does, but this is not still considered microservice. So it is monolith. This is all for now. Next time I will pretty much create the DB for it. Create the DB, discuss what it needs, the cache, the client. The client will be all of them. Wait now. Let me just write it. Client. Shit. Client will be browser. The client is web browser. Shit, hardcore. Web browser. All of them probably. That's all.